Okay, intermediate value theorem questions often are sneaky in the way they sneak things in. Use the table of values below for the continuous good to know. Just because you're given a table of values doesn't mean the function is continuous. They will need to tell you that. Or later you're going to see the word differentiable. That's going to happen as well. So the continuous functions f and g to answer the next 5 questions. I meant to say answer the next 4 questions. That will be corrected on yours. But in the meantime, I'm just going to answer 4 questions, number 2 through 5 questions. Okay, explain why there must be a value c, an x value, in between -2 and 5. Let's take this slowly. In between -2 and 5, such that f of c equals 13.5. Okay, all right, pause. Here's what's happening. I am looking for an x value in between -2 and -5. I'm looking that there could exist an x value in between -2 and 5, such that plugging it in would give me an output of 13.5. In order to do that, I need to meet 2 conditions. Condition number 1, do I have continuity? Yes, they said so. Do I have betweenness? The number they want me to find, 13.5, the output, had better be between the outputs that I'm given. Okay, 13.5 is 13.5 between the outputs associated with these 2 inputs, -1 and 14. Is 13.5 in between -1 and 14? Yes. There you go. Explain why? I just did. So let's do it. First of all, the function is continuous on the interval from -2 to 5. And, okay, condition number 1 is met. Here's condition number 2. We have betweenness. 13.5 is between, it's less than, sandwiched in between. You could put less than or equal to, but it's not really, it doesn't matter either way. 13.5 is between -1 and 14. You can call it that. You can call it f of -2 and f of 5. Therefore, the intermediate value theorem applies. Okay, do you want to write intermediate value theorem every time? No, we call it IVT. From now on, we will abbreviate it as IVT. All right, number 3. What is the least number of c values, those are x values, for which g of c, okay, now we're on the g row, equals 2.5 in the interval from -2 to 6. All right, let's see how this works. First of all, we have continuity. Second of all, I'm looking for betweenness. I'm looking to see how many times 2.5 would logically be crossed as outputs as I travel from -2 to 6 for my inputs. Okay, -2 to 6 are my inputs. My outputs are 1, 2, 3, 4, 3, 2, 3, 4, 5. Okay. As I do this, I'm going to cross 2.5 0 times, 1 time, 2 times, 3 times, 4 times, whatever. Maybe more, because I don't know what happens in between these numbers. But I'm guaranteed to cross it a certain number of times, potentially. Let's see. So if you're really struggling with what I'm trying to say here, then let me pick up a little piece of paper, and I'm going to graph this one very, very quickly. -2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, here we go. -2 has an output of 1. -1 has an output of 2. 0 has an output of 3, and then 4, and then 3, and then 2, and then 3. You don't have to do this. And then 4, and then 5. Ooh, didn't go up high enough. Okay. The logical way to connect these dots would just be to draw them like that. Now, I don't know what happens in between the dots. Maybe they do connect like this. Maybe they connect in some way where there's some craziness, maybe in some infinite craziness that happens in between them. I have no idea. I can't guarantee that. I do not know. But here's what I do know. That on the most basic connecting level, which I'm about to do, not a guarantee that this is what G looks like, okay? But on its most basic level, I would cross 2.5. I would have an output of 2.5. Here's 2.5. 1, 2, 3 times. Okay, you don't have to draw that, but this is how it happens on the table, not necessarily the graph. When you cross the 2.5, you just start counting. So, 2.5 is crossed here. There's 1, 2, 3. Done. Are you going to explain continuity? Nope, they didn't say explain. They said what's the least number of C values. Done. Okay, now they're defining an H function given F and G, actually 2G, and we're subtracting them. Does a C value exist for 0 to 1? Okay, 0 to 1 are my inputs, such that H of C equals -9, and justify your answer. So for justifying my answer, I would talk about meeting the criteria and all that good stuff. So first of all, we're going to have continuity. So let's just go ahead and state that we have continuity, because we have continuity for F and continuity for G. F and G are going to make up H. So we have continuity. Let's check the other though. So I want to check for betweenness. If I were to plug in a 0, let's back up. H of 0 would equal F of 0 minus 2G of 0. And H of 1 equals F of 1 minus 2G of 1. If I were to plug those things in, am I going to get values that are on either side of -9? Let's find out. So I'm going to plug in a 0 for F, and I get -6. -6. Let's zoom this out a little bit. You'll be able to see it a little better. There we go. Minus 2 times, plug in a 0 for G, and I get 3. And that's going to give me -12. Okay, so far so good. Let's plug in a 1 for F, and I get a -2. And then we're going to subtract 2 times G of 1, and that's 4. And that's going to give me -10. Okay, we have continuity. Definitely guaranteed continuity because of continuity. But is -9 in between -10 and -12? No, it's not. So given that, does a C exist? Maybe so. Maybe it does, but I can't guarantee it. So -9 is not between H of 0 and H of 1. Therefore, we cannot guarantee a C value such that H of C equals -9 in the interval from 0 to 1. Okay, it's kind of lengthy. Let me zoom in for you a little bit here. There it goes, right there. And basically we just said the intermediate value theorem does not apply, but we told you why it does not. Okay, same kind of question, but different interval and different output that we're looking for. So we're going to tackle this one as well. And we will find H of 2 and H of 4. And we already are guaranteed continuity. Okay, that's a done deal. Continuity, it's a thing. So we're going to plug a 2 in. When we plug a 2 into our function, we're going to have F of 2 minus 2G of 2. And we're going to have F of 4 minus 2G of 4. And we'll figure out some stuff here. So F of 2, that'd be a 5. You can't see what I'm writing, but you will in a minute. G of 2, that'd be a 3. And that's going to give me 5 minus 6, which is -1. Okay, good. So far, so good. And F of 4, which is 11, minus 2G of 4, which is 3. And that's going to give me a 5. Okay, here we go. You can see what I'm writing now. So, question for you, is 0 in between these two values? The answer is yes. We have met the two conditions for the intermediate value theorem. Therefore, we can guarantee, we don't know what the X value is, or the C value technically, but we do know that there is one that exists. Let's write our explanation. So, H of X is continuous. I want to tell you why, actually. Tell me why. Continuous because f and g are continuous, because they said so. And also, we know that 0 is between those two values. So h of 2 is less than 0, less than h of 4. Therefore, the intermediate value theorem applies. Lucky us, applies, if I could spell it. And there is a C value such that h of C equals 0 for the interval from 2 to 4.